We're going to totally switch gears here. There are basically three concepts to calculus, at least calculus in this class, and those three concepts are limits, derivatives, and the third one are integrals. And integrals are the opposite of derivatives, and that's where we're going to start today, are integrals. So what I want to do, it's also called an antiderivative, kind of the opposite of derivative. So I want to find a function f whose derivative is 3x squared, x cubed. Okay? Is there another function besides x cubed whose derivative is 3x squared? Okay? X cubed plus, I heard someone say 10, I think. Okay, or any constant. So, in general, we could say that f of x equals x cubed plus a constant c. Okay? A lot of times, capital F means that's the integral of lowercase f. In general, that's what it means. Okay, so f is considered an antiderivative. Big F is considered an antiderivative or an indefinite integral of little f. F of x equals x cubed plus c is called a general solution to the differential equation. F prime of x equals 3x squared. So capital F prime of x in this case is the same thing as little f. You okay with that? Little f and capital F prime are considered the same thing. Big F prime of x equals 3x squared, that's called a differential equation because that equation is a derivative. Differential is a derivation of derivative. Okay. So a differential equation in x and y is an equation that involves x, y, and a derivative of y. So anytime we're talking about a differential equation, we're talking that that equation is a derivative of something that we're probably looking for. Okay, so find a general solution of y prime equals 5. In cases like this, I like to rewrite y prime as dy dx. And then, and this is a very, very simple example, but they will get harder, so I want to kind of teach you the right steps here. Then I like to get everything that has a y on one side and everything that has an x on the other. Meaning, if I were to cross multiply, then it would be dy equals 5 dx. Very good. Now, just like I can add 5 to both sides of an equation, or take the square root of both sides of an equation, or divide both sides of an equation by something, I can integrate both sides of an equation. And integrate means start with the derivative and go to the original function. And the symbol for integration is this funky looking S right here. Now, dy stands for the derivative of y. So what would the function be that has a derivative of y? Y, right. The integral of dy is y. What would the integral of 5 with respect to x be? 5x. Good. Now, don't forget your plus c, because the derivative of 5x plus 10 and the derivative of 5x plus 20 are all 5. So you've got to get that plus c. Technically, you also have a plus c when you integrate the y, the dy, and get y. But if you have a constant on the left and another constant on the right, if you solved for y, you would just end up with a single constant on the right side. So you only need to worry about the plus c when you're integrating the x side. If that makes any sense whatsoever. I'm hoping it does. Okay. So when solving a differential equation in the form of dy dx equals something in terms of x, it's convenient to write it in the form dy equals f of x dx. That's basically just separating your y's and your x's. You put everything that has to do with a y on one side, everything with an x on the other. So the general solution, when you integrate dy, you get y. When you integrate f of x dx, you get capital F plus c. Okay, basic integration rules. If you were to integrate capital F prime, so what function has a derivative of capital F prime? F of x, big or little f? It would be big the way that this is written, okay? Because if I take the derivative of capital F of x, I'm going to get capital F prime of x. It can be referred to as little f of x, but that's not what it's asking right here. Now, don't forget the plus c, because whatever capital F of x is, if there's a constant on it, when you take the derivative of it, that constant's going to be 0. Well, if we were integrating c prime of x dx, what function has a derivative of c prime? C. So, I mean, it's just, when you take the derivative of a function, you name it the same way, you just put that prime symbol there. So, if its derivative is capital F, then the original function has to be capital F. Sometimes they will refer to the derivative of big F as little f, but they're going to tell you that, I guess. Don't automatically assume that the derivative of big F is little f. They'll make that connection. But it's a connection that's made a lot.
So where did the dx go?
Okay, where the dx went, what the dx means is that this is the derivative. So when we integrate it, we're basically going up above the derivative. Okay. All right, the second one, what this means is the derivative of the integral of f of x.
Which is the integral.
Yeah, like if you integrate something, you're going up a level. But then when you take the derivative, you're going down a level. So the derivative of an integral will be f of x. Very good. Is there a plus c? No, because the last thing you did was take the derivative.
So wouldn't it be f of x dx? Wouldn't the integral and the derivative just cancel out?
You technically wouldn't put the don't get hung up on the dx at this point. I mean, we won't ever get hung up on the dx, but try and separate yourself from the dx right now. All right, what do you think the integral of 0 would be? A constant. Good. And we just call a constant c. All right, on the second row on the left, k is a constant. So kx, good. Is that it? Plus c, good. Now, why did you say kx plus c as opposed to kt plus c or km plus c? Okay, basically all that dx does is, one, it tells you that it is a derivative, and two, it tells you the independent variable of that function. All right, the integral of k times f of x, you can always pull, and we're going to do this, some more of this later, but you can always pull a constant out in front of an integral sign. So the integral of k times f of x is just k and then times the integral of f of x dx. And that would be the answer. Now, if we wanted to take it a step further and say that in general, when you integrate little f, you get big F, then I guess we could take it a step further and say, okay, well, that's k times big F of x plus c. You don't need to put parentheses around f of x plus c because k times a constant is another constant that's just a constant. Okay. Right. Kelly? Well, think of k as 5. What has a derivative of 5? Okay. Brian? No, it wouldn't be wrong. All right. The integral of x to the n. What generally happens when we take a derivative, what happens to the exponent? It goes down. You subtract 1. So if we're integrating, what's going to happen to the exponent? We're going to add 1. So it's going to be x to the n plus 1. But there's going to be a coefficient in front of here. Because if I were to take the derivative of x to the n plus 1, what do you do with the n plus 1? You bring it down in front. It's 1 over n plus 1, x to the n plus 1 plus c. Okay. Because think about taking the derivative of x to the n plus 1. I need to bring that n plus 1 down in front, and I need for it to cancel so that my final derivative is just x to the n. We're going to do this with real numbers in just a second. Well, if you take the derivative, basically I need to find something whose derivative is x to the n. So the first thing we discovered was, well, we need to start with x to the n plus 1. So if this was not here in front, then when we take its derivative, it's going to be n plus 1 times x to the n. But the original problem is just x to the n. Because when you're taking the derivative of our answer, you're going to multiply n plus 1 times 1 over n plus 1. Just 1, yeah. Okay, the integral of cosine x. What function has a derivative of cosine? Sine. Is that it? Just sine x plus c. I will be lenient on your very first quiz about the plus c, and then I will get pretty stingy. Or pretty picky. All right, what function has a derivative of sine? Negative cosine. Good. Don't forget that negative cosine. Negative, and then plus c. What function has a derivative of secant squared? Plus c. What function has a derivative of secant tan? Secant x plus c. Negative cotangent x plus c, and negative cosecant x plus c. We will learn the integrals of just plain old tan, cosecant, cotan, and secant, but not for a few weeks. So right now, in terms of trig functions, we're limited to integrating things that have known derivatives.